Hey everyone, welcome back to Cruise class. Now in today's class we'll be doing some examples of how we can apply trig ratios to solve simple trig problems. Now in this example we see a right angle triangle and we have the side AC, we have the side AB, and we have the side CB. Now we want to find the side AB. They label it as X in this question and we have one known angle. So to find X, we have to first realize that AB is the same thing as X. Now, the angle of interest is 22 degrees. So we're going to use that angle as our reference angle. Now, the sides that we do have is side CB, which is 80. 80 is the hypotenuse. And X, which is the unknown, is the opposite to 22 degrees. So therefore, if we have the opposite side dealing with, and we have the hypotenuse dealing with, the opposite and the hypotenuse works out to be in sine. So we have to use sine. So therefore, the sine of 22 degrees must be equal to the opposite over the hypotenuse. And that will give us X being 80 times sine 22, which will give us 30 meters. So therefore, X would be 30 meters. In example 2, we want to find the unknown angle, theta. Now the unknown angle would be, let us see the reference lines. We have one reference line of 20, and 20 is the opposite to theta. And then we have 60 being the hypotenuse. So therefore, opposite and the hypotenuse once more is sine. So the unknown angle would be sine theta, which is the unknown angle, would be equal to the opposite over the hypotenuse. So therefore we have to find the inverse of sine. So theta will be equal to sine inverse 20 over 60, and to two decimal places that will be 19.47 degrees. Now, in our next example, we have another right angle triangle, and we have X right here is opposite to the reference angle 42, and 40 meters, this line right here would be the adjacent to 42. So we have the opposite and the adjacent, so that would be tangent. So the tangent of 42 must be equal to the opposite X divided by the adjacent. So therefore, X must be equal to 40 times tan 42, and that will give us 36 meters. Now, in the next example, we have the opposite, 32, being the opposite to 38 degrees, and X here being the adjacent to 38 degrees. So this will be another case of tangent. So therefore, to find X, the unknown side, it would be tangent of 38 equal to the opposite, which is 32, over the adjacent, which is X, and therefore X would be equal to 32 divided by tangent of 38, and we will get 41 meters. Now, moving to another example, example 5, we want to find the unknown side X. We have an angle 38. We have the hypotenuse of 120. Now, if we already have the hypotenuse and we have the reference angle as 38, X would be the adjacent to 38. So adjacent and hypotenuse would be cosine. So therefore, cosine 38 would be the adjacent, which would be X, divided by the hypotenuse of 120. Therefore, X would be equal to 120 times cosine 38, and will give us 94.56 meters for the unknown side X. Our last example, we want to find the angle theta. However, this triangle is an isosceles triangle because two sides are equal. As you can see, 50 here and 50 here. Now, if those two sides are equal, what will happen is that when we bisect it from A to D, we'll have a right angle formed here and another right angle formed here. Now, if those right angles are formed, what will happen is that we can now apply the trig rules and know what trig rules we can use. Now, for this side, theta, what we will realize is that half of B, or 30 meters, is from B to C. So half of BC would be 15. So B to D would be 15. And this side right here is the hypotenuse of 50. So if we have BD being the adjacent to theta and 50 being the hypotenuse, as we already know, adjacent and the hypotenuse would be cosine. So therefore, cosine of theta would be 15 divided by the hypotenuse of 50. So therefore, theta would be equal to cosine inverse 15 over 50, and that will give us 72.54 degrees. And those are just some simple examples of how we can apply the trig ratios.